My name is Tran. I'm working in query performance at InfluxData.
My name is Andrew Lamb. I'm working on query processing at InfluxData. The key when you're down in the code and you find some bug, I think in order to treat that as a positive experience, not like necessarily as a negative one, you have to sort of have a grander plan of where you're headed, right? You have the design, you know where you want to go, and then when a bug inevitably comes up when the code doesn't quite do what you expect it to do, being able to refer back to like what, you know, your idea of what it should do and sort of triangulate to figure out like where the bug might be, I think is key to building big complex software systems.
Yes, exactly. So what I found is the bug is a part of our process. When we write a new features, then we always introduce new bugs. And as our daily job, we have to figure out what's the problem. When we run into the bugs, figure out what's going on, find the root cause, and then fix it.
Yeah, and in some ways I think bugs are a consequence of having real people use your software, right? You can sort of in isolation design the software the way you think it should work and get it all working the right way and write your tests and everything works great. And then as soon as you turn real people loose on it, they have a tendency to find all the corner cases that you never even imagined that they would. So I think I've learned over the years not to take that as a failing or something we could have prevented entirely up front, is that you have to get it good, get people using it, and then be prepared for that feedback loop, which in some part will inevitably include bugs. Like that's how real software gets made.
And many times when we ship the products, customer discover bugs and send it to us. And it's not, at that time we don't panic. We say it's a normal process and we just look into the bugs, figure out what the problem is, and then fix it.
Yeah, one of the things I learned at one of my other startups is if you sit there and obsess about making it perfect before you ship, right, or making sure you get everything right, what happens is it either takes really too long to ship or you build something beautiful that's not actually what people want. And so I think there's a real balancing act between, you obviously can't ship software that's just terrible and like doesn't work for people, but you have to ship it like that's literally good enough. It's not probably going to be bug free if you ever want to ship it in a real timeline. But then you need to be prepared to evolve it based on the feedback that you do get.
Yes. So recently we got a bug from customer saying that we got a wrong result.
And if you ever worked on a database or sort of other low-level systems, wrong results is very, very bad. But like that's typically the one you would jump on as soon as possible.
So the first thing we try to discover is what is the commit that caused the problem. So in order for us to resolve the problem as quickly as possible for customer, the first thing we do is to revert that commit so it won't affect the production as soon as possible.
It was very cool to see. I think there were 3 or 4 engineers involved, and very quickly we identified sort of which commit had caused the problem, and immediately rolled that back. And I think that obviously gets the customer back to a good state, but then it also gives us as engineers breathing room to not go really spend the time to figure out what was wrong and fix it for real, right? So I think the very first thing we tried to do is you tried to reproduce it in a controlled environment. You know, in this particular example, it's real customer data. You can't necessarily share that very broadly, right? You have to be careful with how you handle it. And so the symptom that we're seeing now, the challenge will be to translate it, and so we can reproduce it with like just test data.
Yes, and now we have a local reproducer, but with a large data file that we cannot share with anyone outside. We need to narrow down that reproducer to a very small reproducer so someone else can work on a fix.
It could be very frustrating if what you're just trying to do is find some other example of reproducing, but I always like to think of it as kind of like an intellectual puzzle. You know the answer that you need, but you've got to now find how to fit all the pieces in place to trigger the behavior that's causing trouble. So I think in this case we identified the pieces early on.
At first, one of us worked on the reproducer individually, but we could not figure it out what the problems, we could not reproduce it. However, when we sit down with each other and each other fit a hint to the other, and then we say, oh, we need to do this and we need to do that. For example, in this case, we say, oh, the data type must be the dictionary. It's not just normal varchar, but it's dictionary. And then the other say, oh yeah, I know how to do it, how to cast it. Then we end up have a very simple reproducer.
Yeah, and I think by the time you get to a system like Influx, which is mature and running a bunch of customer queries, like bugs aren't simple anymore to reproduce. Like in this case, as Nyan was saying, it needs multiple input partitions, and it needs to be dictionary encoded, and you need to have more than one, and it needs to be count distinct. So getting sort of all those things to line up and sort of be the key that unlocks the behavior, I think it's frustrating going through it for sure, but when you finally get the reproducer, it's like a huge, like an endorphin boost. Like it's very satisfying.
Yes, exactly. So for me, working on bugs is just like solving a puzzle. It's so satisfying when you say, oh, we got a reproducer, even though we have not solved the problem yet. Yeah. And the next step is we need to find a solution to solve that problem.
Once you have the reproducer, finding the fix is actually almost always very, very straightforward. But actually, like, getting that reproducer is the hardest part. But as soon as you have that, that means you really understood what the fundamental problem was, and you're not just guessing anymore. And I think that's the key. And so I think debugging can be very frustrating if you're not tracking a methodology and you don't have a way to reproduce it. You're basically just guessing, right? So you're just guessing, trying things, and that can be very frustrating because you can't really feel like you're making progress. I think there's often a class of things too where a customer notices a behavior, like maybe it doesn't have the performance they expect, or it has some other behavior that the customer would prefer it does something different. You end up with interesting conversations about, is something a bug or not? And often that will come down to like, is the software working as designed? And that's a different question of whether design could be improved. And so I think making that clearer, that's often helped me too, where instead of arguing back and forth about whether something's a bug, right, you can acknowledge like, no, the system's working the way we designed it to. It's clear, it could be better in this particular way, but that's an important distinction to draw too when you're looking at these complicated things.
In many cases, when we run into a bug, in order to fix it, we say that it can be a big feature, and it takes time to build that feature. That's when we need to sit down and talk with the team and talk about the design and talk with the management team to say what is the priority, and there are different approaches and what approach do we want to pursue, and if it's 1 week or 2 months, we need to have a right schedule for that, and sometimes we need to ask customer what they want. We hope our conversation provides you insights about our software building process.
Try out the software we built using InfluxDB 3.0.